Let me introduce you the materials that we're going to use. We have tobacco leaf, ampalaya leaf, okra leaf, we have also a papaya leaf. We have a tweezer, a glass light, we have also a dropper, a utensil. We're going to identify the different properties of leaves. Okay, the next step that we're going to do, we have to measure the different length and width of different leaves. We have to... Okay, let us measure the papaya leaves. A papaya leaf consists of 18 centimeter length. A papaya leaf consists of 12 centimeter width. Let's proceed to the okra leaf. An okra leaf consists of 10 centimeter length. And the okra leaf consists of 12 centimeter width. Okay, let us proceed to ampalaya leaf. Ampalaya leaf consists of 8 centimeter length. An ampalaya leaf consists of 7 centimeter width. The last one, we have tobacco leaf. The height of a tobacco leaf consists of 5 centimeter, and the width of a tobacco leaf consists of 8 centimeter.
While observing the edge of the papaya leaf, we noticed that it's very different from the other leaf that we observed. Because the edge of the papaya leaf that we placed under the microscope was plain, we didn't see a tiny hair on the edge. The first thing that we've noticed of papaya leaf under the microscope is the veins, and it's unique because of the pattern of the linings. We can see that the leaf is made up of numerous cells that are densely packed together. The color of the papaya leaf is yellowish and the lining is yellow.
Let us identify the property of an okra leaf using the microscope compound.
Our observation of the physical appearance of the edge of an okra leaf under the microscope. The edge of an okra leaf reveals intricate and delicate structures that are not visible to the naked eye. We've noticed that the edge of the okra leaf is lined with the tiny hairs and cells that create a distinct boundary between the leaf. Upon placing a body of an okra leaf under a microscope, several distinct physical properties were observed. The first thing that we have noticed is that there's a lot of dots and the color is yellowish. The okra leaf also exhibited a vein structure that was visible under the microscope.
Okay, so the next that we are going to examine is the ampalaya leaf. We're going to cut the edge.
Upon placing a small piece of the ampalaya leaf under the microscope, the first thing that we've seen is the presence of the tiny hairs along the edge of the leaf. While observing the body of an ampalaya leaf under the microscope, one of the first things that stands out is the veins that run through the leaf. We also notice the small dots in the ampalaya leaf and the color is yellowish. The next we will examine is the tobacco. Our observation about the edge of a dried tobacco leaf under microscope, one of the first things that becomes apparent is the structure of the leaf itself. We still notice the tiny hairs, but it's very different from the other leaf because it is dried. The tobacco leaf is very different from the other leaf that we already observed. The first thing that catches in our eye is the intricate pattern of veins that run through the leaf, especially the color of the dried tobacco leaf. It's totally red and it looks like a lava.
And now we are going to examine all of the leaf together with adding the diluted HCl.
The first thing we observed when dissecting the papaya leaf's body with diluted HCl, it was plain and the root line was a pale yellow tint.
And now we're going to examine the okra leaf with the adding of diluted HCl.
There is a cystolytic hair along the okra leaf's border, which we found when we examined it with diluted HCl.
And now we're going to examine the body of an okra together for adding the diluted HCl. We're going to examine the body of okra with the diluted HCl in the compound microscope.
The first thing we observed when we examined the body of an okra leaf with diluted HCl was that it was completely green and filled in many dots.
And now this is an ampalaya leaf together with diluted HCl. And now we're going to examine it in the compound microscope.
By applying diluted HCl, we're able to observe the ampalaya leaf's body, which consisted of little spots with several yellow-colored specks inside of them. While observing the ampalaya leaf with diluted HCl under the microscope, we observe a significant change in its appearance. The cell walls appeared to have softened. The tiny hairs along the edge was destroyed because of the acid.
Now we're going to examine the tobacco leaf with diluted HCl.
Our observation of the edge of a tobacco leaf under a microscope, the first thing that we notice is the different layers of cells that make up the leaf. When we place a dried tobacco leaf under a microscope, its edges can reveal intricate details about its internal structure. Because of the diluted HCl we put it in a tobacco, it helps us to highlight certain components of the leaf, making it easier to observe and analyze. As the HCl reacts with the specific compounds in the leaf, the edge became plain and the tiny hair was damaged. While putting the diluted HCl into the dried tobacco leaf and placed in a microscope, the first thing that caught to our eye is the outer layer of the leaf because it's changed and it looks like sun. We also notice floating bubbles on the surface of the body of dried tobacco leaf. Based on the video we got from the internet, there seems to be a gap in the body. The color of the body was brown and then there are some darker brown on the body of the leaf. Based on the video we got from the internet, we saw that it didn't have a cystolytic hair and the color of it was brown. Upon researching, there is a specific observation of marijuana when placed in diluted HCl and examined under a microscope. However, it stated that adding HCl to a sample and examining it for effervescence under the light of a microscope can produce similar results with other substances, not just marijuana. When observed under a microscope, these plants exhibit a unique characteristics such as the trichome structures on the leaves. According to our research, when observing the body of dried marijuana with diluted HCl under the microscope, one of the things that we can see is the several interesting features. The acid may cause certain compounds to react and change the color. Before it placed to the microscope, the color of marijuana is brown, but after it placed to the microscope, it became dark green.